Okay, drag and drop the interface here. Now the ray into the interface. Make it bigger. Choosing extra slur. Okay. And then now we just need to copy them 4 times, holding the control button. So second line. Okay. Okay. And then in the in every single block we will set up now. Oh, sorry. So maybe it's too fast. So delete this one. Yes. Set up first. So in the processing time, in the soup, we have the interval first. So interval here is not the constant. It means that it's not generate the MU frequently, but it will generate the MU uh, time by time. So it's not continuous. So it's based on the uniform. And then the uniform is from 1 minute to 5 minutes. So it means that for every 1 minute or maximum for every 5 minutes, it will create one MU, one new MU. Okay? Not every 1 minute, not every 5 minutes, but in between 1 and 5 minutes. Sometimes 3 minutes, new MU going now. Sometimes 1 minute and 30 seconds, one new MU going now. So this is uniform distribution from 1 to 5 minutes. Okay. And about a single block, uh, the single block, so maybe the processing time is 1 minute. Okay. Yep. So we have only the truth is the random event. Okay. Yeah. Yep. And just simply copy everything. Okay. Then if I run the simulation in 1 hour, 1 hour. Okay, this is 1 hour. No need to show summary report. And then how many products that we can produce. Okay, if we have 1 minute, 1 hour, so maximum product that we can produce is 95, 59. Okay, and then if the so produce the MU every 5 minutes, so it means the maximum that we can have is 12 or 11. Okay, then let's check. So here, okay, so now you see I have the same value. Okay, even that I have the different product, a different production line. Okay, it's because that I copy them. So what if I do it in the other way? So here, so I create now material flow. So here, so here, so here, single block or station, and then ray, ray, ray. Okay. Okay, and then display. The display, we can copy. Set. Then show here uniform from 1 minute to 5 minutes. This is also the same. 1 minute to 5 minutes is the same. 1 minute to 5 minutes. No, sorry, uniform. 5 minutes. Okay, double check. Uniform. Okay. Yep. Then this is 1 minute. This is 1 minute. This is also 1 minute. This is also 1 minute. Reset, run the simulation. Now you have, okay, the same setup, but different results. Why? Again, this is because that we have unconstant number here, the random number here. Okay, but the thing is, if we reset and run the simulation time to time, okay, the result that we have always the same number. Okay, and of course, if you run it on your own computer, you will have the different result that what I have right now. Is that correct? That you will have also, or you have the same result as what I have here, 18, 24, 21, and 18. You have the same number or you have different? So you should have a different number. But what I have
Did you do you change something in the event controller? Do you set any time in this?
Yeah, in 1 hour.
1
I
hour.
run the simulation in 1 hour. And then after 1 hour, I collect the data here. After 1 hour, my first production line give me 18 products. My second production line give me 24 products. And the third one, 21. And the last one is also 18. Okay, so the same setup, but because that we have the random event, okay, so we will have a different result. Okay, so here in step number 4 in the product, they will ask us to change the random seed value of station number 2. Okay, so maybe I can change here. So how to change the random seed? Okay, you can change it with the method, or you can simply choose the station, press F8, okay, and search for the value random number. Okay, random number sheet here. Set it to 20. Click OK, close it, and then show 3, F7, oh no, sorry, F8, click R to shut. Okay, here, put it also 20. Okay, and see what happened. Okay, and see now, you see that we have the same result for the soup 2 and soup 3. Because if they share the same random sheet value, they will perform the same result. Okay, this means that just imagine that if you have the same environment, the same condition, the system need to perform the same result. So this is the principle of the model. Okay, but then how we capture the statistic from the natural or from the nature. Okay, it means that we need to run the simulation multiple times. Okay, how to do it? Reset and place, reset, play, reset, place. No. Why? Because when you reset something, you play, you have the same result here. Why? Because the condition on the environment that you set here is the same. So it will be from the same result. So how to change the environment surrounding the system and run it multiple times? We will use the here the experiment manager. Okay, so please find in the tool. This is last tab in your toolbox tools, and then you will find the experiment manager. Okay, with the experiment manager, you can have you run multiple or run the simulation many times. It's just like it have you roll the dice 10 times, 100 times, 1,000 times and collect the data for you. And here the same experiment manager have you run the same system multiple times. And what they change is they change the random seed value to generate different environment, different condition, and then based on that, the system react with that kind of changes, and then they have the data, they collect the data, they put it in the statistic. Okay, how to set up? For example, here you can set up the output value, define our. So where is the window? Where is the window? Where is it going? Okay, guys. So sorry. So when window is going somewhere else. So here. Okay, sorry. I need to stop sharing and push to another screen. Stop sharing. Share my screen. This one. This one. Okay. Define output. Okay, now there is a window. Okay, when you click on define output value, so this is the value that you want to observe. Okay, here I can drag and drop the value that I want to see here. Okay, enter to have the second line. Sorry. Sorry. Here. Make sure that you could check if the avatar is okay. Okay. Good. They don't allow to show this one. So maybe I will say it's surrender. Num what is the value that we want to see? F8 and then 5 for the value. Okay, maybe static num in or num mu is the one that we can see now. I think static num in. Okay, static delete. Okay, so I will use this one. Static num in. So this is num it. Okay, and here the same rank 1 dot started num it. Here and then here the same. Okay, and then now again experiment manager, how many experience that you want to do. So I want to do it maybe 10,000 times. Okay, make sure that you reset everything. Okay, reset, and then you can start your simulation model, and then they will give you. Okay, so my computer is very powerful. It can run 10,000 experience in 0.012 seconds. Okay, I don't know how about your computer. Here you can see. So this is the statistic that we should have for the random or for the stochastic model. It's not a fixed number. You cannot say the throughput anymore. Fixed as a fixed number. You should communicate or you should put in the report as such kind of chart inside they call it the box chart, and then communicate in the mean value. Okay, you will have the throughput for your first production line is 19.4 products at the mean value. Standard deviation is mean that one part more or one part less around. Okay, and the minimum that product that you can produce is 18. The maximum that you can produce is 21. But how many chance that how often that you can have the 21 at the finished product? So you look up here, you will know how many chance that you will have. Rarely happen, less than 1%. Okay, what is the graph tell you? So this graph tell you, okay, 50% of the chance will fall into this box. Okay, 50% of the chance will fall into this box. Another 20% will be under, and another 10, another 50% means that another 25% will be under here. Another 20%, 25% will be upper here. But 50% of the data will flow into this area from 18.5 to 20.5. 50% chance that you will have such kind of throughput. Okay, for the first system, and then for the second one, okay, the second one perform differently. So they will have minimum 20 product and then maximum 24. The mean value is 21.8, and then you will know that 50% chance that we will have more than 20 products. Okay, 50 chance that you have more than that kind of system. So if you receive the customer order and they want to have 20 product, okay, and then you know your system can afford or can fulfill the customer requirement on time, because of the chance that you get the 20 is 100%. Okay, sometimes you will have more of the time, but you will have more but at least you reach to 20, and then you can fulfill the customer order. Okay, with all of the uncertainty element inside your system. After run thousands of experiments, and then you know that your system, in the worst case, can still perform as the minimum requirement of the customer, and then you can confident to say that, okay, I can take this order. So this is how we scope with, or how we deal with stochastic or the random event in our system. Remember, keep in mind, when you have some kind of random effect, defect, reject something with the defect rate, you need to perform the simulation multiple times. And how to do it? You need to do it with Experiment Manager. You cannot do it with simply click on the reset, and play. So this is only for the deterministic or the fixed scenario. And then for testing the behavior of the system, after logic is correct, for example, to testing, okay, red need to go to buffer red, yellow should go to buffer yellow, and so on. It's just for testing. But if you have, for example, here, the processing time is not constant number, but uniform, it means that you need to run the simulation model with the Experiment Manager. And the more that you run it, the more precise that you have. Okay, for example, I can run here 1 billion simulation run. Okay, 1 billion means 6 0, 1 2 3, 1 2 3. Apply. Okay, not this one, the other one, this one. The Experiment Manager, you are correct. Reset, and start the simulation. And now with the million time, you know, my simulation is running. Okay, 5,000 already, 6,000, 7,000, 8,000, 9,000, 10,000. Okay, let's see how long does it take, or run a billion times the simulation. Okay, I think it take a while. Then how about you guys? Can you try it on your own computer? So maybe your computer is more power than what I have here, and then it takes maybe 1 second or 2 seconds to perform 1 billion simulation run.
Dr. Bảo, can you?
I'm not Dr. Bảo. I'm Mr. Đức.
Sorry, I'm sorry. Sorry, Dr. Đức. Can you perform again the part where you define the output value? So that, yeah, I missed you that part. Yeah.
Okay, sure. Yeah. So to define the output value, you just here in the definition, you click on the button define output. Okay, and then here, this is the data that you want to collect. Okay, you can collect different data, but here you have only one data to collect is start number. Of course, for example, you can collect the value of the show creation, or if you have the single block, have the processing time, you can check. So what is the average processing time of your signal of your station? Here, what you write here is the address, the root. Here means, so maybe the ultra wide is not good for seeing this one. So maybe let me share the smaller one. Okay, this one. Yep. So here you have, can I make it bigger? No. Then I will give you here. So maybe Okay, can you see the letter or the inside here?
Yes.
Okay, it's quite small. Okay, so what is written inside the column? The first column is the value that we want to observe. Okay, so what is written here is the root dot rand dot start limit. So what is root? Root is mean this one. Okay, and then dot rand one root. What is root? No, root is different. Root is mean that the frame that you are staying. So root is mean that this is the root of this table. So this is the model. Okay, and then the object rand, and then the attribute that you want to observe. I want to observe the start limit, so I write here start limit, then click apply. Okay, that's it. Okay, let's keep running. So I have here, okay, 100,000, 103, yep, thousand already, 135,000, 126. Okay. Okay, so it will take forever, so maybe I will stop here. Yes. Okay. Why you cannot stop? Okay. Reset. Maybe 10,000 or 5,000, maybe better. Apply. Reset. Yes. Reset here. And then start. Okay. 1,000. Yep.
Mr. Đức,
Mr. Phong. Yeah, Mr. Lộc.
could you please explain again, like when you set the observation per experiment, and then you turn on the start, and then the computer starts to count something like observation, something like this, and I'm still confused about what is the meaning of the experience manager now.
Okay, so the observation is mean that how many times that it run the simulation model. Okay, I set two observation. It means that I run the simulation model 2 times with different environment, with different random seed value, and then I observe the result. So it means observation. Okay, I set here the number of observation per experiment. I set it 50,000. It means that I will run the same experiment, but I will run it 50,000 times. And then I take 1 minute and 20 seconds to do it. And here is my summarized. Okay, so the value here is more concentrated here. So I more or less have the product between 19 to 21. Okay, more concentrate the result. Okay, and here we have experiment. So what experiment? So you can have multiple experiment. Okay, in one simulation model. Okay, so for example, I can change the setup of the machine. Okay, so processing time 2, processing time. Then the next experiment is double 4 minutes. It means that different setup in the system. It means different experiment, and with different experiment, please do it 5,000 times or 50,000 times. Okay, it means that we will have in total 100,000 times that we run the simulation. Okay, again, here we have observations per experiment, because that we have only one same model one same setup of simulation model. So it means that we have only one experiment. Okay, so if we have here in the first experiment, I do it, the processing time is 1 minute. In the second setup, I want to try out. So if I do the processing time is 2 minutes, what will happen? So it means that the 1 minute with the 2 minute processing time is totally different system, totally different model. And it means that different experiment. Okay, but for one experiment, I want to do it 5,000 times. Why I need to do it 5,000 times? Because there is a random value. What is the random value here? Is the reaction of the MU. The MU not react every 1 minute, not every 5 minutes, but it's a random number between 1 and 5. Okay? So that's the reason why we need to perform the simulation multiple times, 1,000 times at least, to collect enough data to make enough observation to make the conclusion. Okay, it's just like that when you observe something in the nature, and then just one time you don't sure that it will always happen like this. You need to check, watch it a couple of times, and then if it always perform or react in the same way, behave in the same way, so it means that this is a fixed behavior of the system statistic. But when you watch something, sometimes it happens like this, sometimes it happens like that, and then it have the different distribution, and then based on the statistic, it means that the first time the value is 1, you write down, you record the result, and then you result it 1,000 times, then you have the more or less the data, and based on the data, you make the graph, and then you can make the conclusion. Okay, this system follow the normal distribution. This system follow the uniform distribution, negative, and so on. Okay, there are several behavior of the system. For example, here we have show here in the graph. Here, for example, we have here normal distribution. This means that the reality will focus, or the result will be concentrated in the mean value, and for the minimum value and maximum value, the chance that it happen will be very low. And for the uniform distribution, so this means that all of the cases will have the equal chance to happen. And of course, we have many more, not just this. The figure, for example, your colleagues showed us before, when we have here, yet uniform F1. Okay, and then, for example, we have a lot of distribution. For example, we have negative. So here, for example, we have the this is, we call it the negative exponential distribution. This means that it will happen more in the beginning, high chance to happen, and then the longer time it will have the large chance to happen. For example, if we have the canteen or the restaurant open in the during the lunch break, and then the number of the people that going for lunch will be likely happen around 12 to 1 o'clock, and then in 4 o'clock, the number of people go to the restaurant will be only 10%, but 50% of the people will be go for lunch around 12 to 1 o'clock, for example. So they follow the negative exponential distribution. Okay, and for example, another distribution we have for here, maybe famous one, Poisson. So the Poisson distribution is just like the normal distribution, but with a smaller population or lower data. Okay, if you have a lot of data, and then your system will perform as a normal distribution, but sometimes you cannot observe a million cases. You can have around 100 of cases, and then your system more will be in the Poisson distribution, not the normal distribution. Okay, again, this is from the stochastic or random event, and then from the statistics point of view, that we need to present the results in the statistics table or in the box chart, not presented as a fixed value. Okay, so this is how we deal with the stochastic event or stochastic simulation model. Is it clear, Mr. Lau?
Yes, it's very clear to me right now for your explanation. Thank you.
Yep, you're welcome.
Thank you.
Yep, so of course, in the project or in the many advanced exercise that we will do in the future, we will focus on the real system. It means that we need to run the simulation, I think, more than one time, at least 1,000 times to collect the data. And then based on the data, you will make the decision, is it good to go with this kind of setup or it's too risky to have to receive the order to accept such kind of system and so on. Okay, so normal, the random is very likely happen in our system. Okay, this mistake is very rare. Okay, of course, then now I think that yeah, this is more or less on for today, and maybe yep, you can go to breakout room and yep, do your own exercises if you want. If you still have question, of course I will be here. Yeah, support you with all of my best to explain again what you unclear about exercise, or if you have any idea about the system that you want to model, the system that you want to make experiment. Of course, I will be here for support. But first of all, do you have any question regard to today's lecture? First, about the syntax, add question mark. Second, about the random event, and then how to perform the simulation when we have the random event. So this is more two things that you need to take away for today. Again, do you have any question, or you still don't understand what is the syntax about add or question mark? Okay, and the second thing is about how to do, how to perform the simulation model where I have the random event in the simulation. Okay, yeah, so please feel free to yeah, pour out your question, email just or right here. Otherwise, yeah, so please just go to your breakout room. I hope that it will help you to work by yourself in the exercise practice. You ask your colleague first, and then if he or she cannot solve it, of course you can request my support. I will go to your breakout room right away. And yeah, just let me assign room. Yeah, So you can free to use the room.